Alright, hey guys, we're going to start with a cool little lesson here today on a lady that says she can smell the Parkinson's disease. So she is from the UK and she says that she can smell a subtle musky odor, and that signifies that someone has Parkinson's disease. She first noticed this on her husband and she thought it was just from him working long hours in the day and just being all sweaty. But then he was diagnosed 6 years later. And Joy suspected that odor was because of the disease. So scientists, being scientists, wanted to find out if Joy was correct. And so therefore she was given 12 different t-shirts, and each worn by a different person, some of whom had Parkinson's and some who did not. The t-shirts were given to Joy in a random order, and she had to decide whether each shirt was worn by a Parkinson's patient or not. So now we're going to watch a little video about this, and then we'll ask you a couple of questions that'll pop up, and therefore you can answer those, and we'll go further with that in a second.
Joy Milne first noted something odd about her husband's scent when he was 45. Shortly afterwards, he was diagnosed with Parkinson's. Now universities are testing if it's a coincidence or a newfound precaution. Here's Mike McCarthy from our British partner, Sky News.
When she was a teenager, Joy Milne started to realise that she had an acute sense of smell. But it was only when she noticed a change in her husband Les's odour that the incredible potential of her super sense became clear.
He was the anaesthetist. He was in a close situation in theatres and he was working long hours, and I presumed, and the Parkinson's tiredness had kicked in then, but we didn't know that. And because he was so tired, I just thought, well, you're not showering enough, and I said so.
At first, Joy didn't know what the smell was until she recognised it in other people and said so at a meeting to discuss Parkinson's.
And I thought, this is it, this is the right moment. And I stood up and said, why are we not using the smell of Parkinson's? I can smell it in this room all around me.
Now at Manchester University, researchers supported by the charity Parkinsons UK are harnessing Joy's special skill.
Once Joy's incredible ability had been recognised, she was given by the university a number of t-shirts. Now, half of them had been worn by Parkinson's sufferers, the other half by a control group. She got them all right, apart from one.
Alright, so after going through those questions, let's discuss them here a little bit, what it would kind of play out to be. So, why would it be important to know that someone can smell Parkinson's disease? Well, let's talk about possibly maybe like some early research, right? So they can get early research. And I know my handwriting stinks, so bear with me. Alright, so also this could lead to possibly figuring out what causes it, right? So you figure out the cause. And then we could say maybe like just early detection, right? If you're able to find out, start treating someone earlier, maybe give them a little bit better life. So early detection. Alright, so we got those three. It's good enough to start out with that. Next question we talked about here was how many correct decisions out of 12 would you expect Joy to make if she couldn't really smell Parkinson's and was just guessing? Well, let's think about that, right? You either get it right or you get it wrong. So you technically have a 50% chance, right? You're either going to guess correct or guess wrong. So it's a 50-50 chance, right? So if you say that out of 12, we should get 6 right then. So hopefully if she's just guessing, we should say she'd probably get at least 6 right, okay? Because she has a 50-50 chance, right? Okay. let's see, with the last question here we dealt with on that little break. How many correct decisions out of 12 would it take to convince you that Joy really could spell Parkinson's? Well, hopefully most of y'all said either getting all of them correct or a lot of them correct, right? Because if she's only getting 6, well, she used to be guessing. So you'd really want her to know her stuff. So she should get, if not, let's say maybe like 10, at least 11 or 12, right? Somewhere in there. So we're going to say just a lot. A lot is the answer we're looking for here, really. And you could have put numbers in there. That would have been fine. You know, 10, 11, or all 12 of them, right? All right, so we're going to see what happened on her guessing here. We'll watch a little video and we'll come back.
She got them all right, apart from one. That person went on to develop Parkinson's.
Scientists believe that Parkinson's may cause a subtle change in the skin's natural oil, and are working to develop a test that could help diagnose the disease even before physical symptoms occur.
This is a significant new area to research into. There are many scientists looking to do early diagnostics. We all want to do that. We want to be able to tell people, unfortunately, but tell them that they've got a disease earlier than is currently happening. If we can find that molecular signature, find a test for it at an early stage, that's when the breakthrough will be. So this is the beginning of the breakthrough.
Joy's husband Les died earlier this year, but the hope is that through science and research, the phenomenon that is her sense of smell will help reverse the destructive power of a disease for which, as yet, there is no cure. Mike McCarthy, Sky News, Manchester.
All right, so pretty crazy, right? So she got all 12 of them right. The scientist thought she was wrong, but then that 12th person actually came out to having Parkinson's. So since we can't really do this in class with a simulation, let's go ahead and do it on here. Now I'm using the website called Staplet, and the link will be in Canvas as well for our class. And I would suggest you guys use it and play around with it. It's pretty cool getting to see things actually work. So with this, we'll start out here, and we're using the one categorical variable in a single group. So I went in and labeled it already. So the variable name is just Parkinson's. I'll just label it up top here, top right there. And so I also labeled the category name, number 1 here, saying correct and incorrect. So initially, how many did Joy get? She got 11 correct. And then how many did she get incorrect? Well, she got 1, according to the scientist. Well, when we do this, just click Begin Analysis down here. And of course, that gives us a nice little bar chart here, okay? You can start out with seeing that with the frequency here. So of course, as it shows, 11 here for correct and 1 incorrect. Now you can also play around with this as well to see the different setups they have. So we also have a segmented bar chart, which some of y'all may have heard about before and some may not. We'll get into it, but again, we're dealing with relative frequency, which is your percentages over here on your y-axis. And dealing with this, it just has a single bar here showing, and the Parkinson's for correct was 0.9, so 90% of them, right? And then she got 10% of 0.1 right, or incorrect, I'm sorry. She got that 0.1 incorrect. So you segment a bar chart, and the last one they give you option-wise on here is also a pie chart. Which pie chart, you can hold your mouse over the sections of the pie chart, and it gives you the percentages that it plays out to be, okay? Also underneath there, on the summary statistics, it shows you correct, incorrect, and the total, and your relative frequencies for that. But now we're going to go down here on the bottom part of this, where it says perform inference. So we want to deal with this and saying inference procedure is simulate a sample count, and we're going to look for the category to indicate is correct, because we want to know how many she got correct. So when we're simulating this, we're going to do a true proportion is equal to a hypothesized value. Now, you may not know what that is talking about yet. We'll get into that a little bit more in explanation further on in class. But what that's going on, hypothesized proportion, is talking about here is we're dealing with 0.5, right? Because we said she had a 50% chance of getting it correct or getting it wrong. So she could guess right or wrong. So your hypothesized proportion, she has a probability of guessing it right is 50%. So in decimal, it's 0.5. So we're going to start with this. Now, I believe you start out here in class, we've got 18 of you guys. So I'm going to click this 18 times and see how this plays out. So I'm going to click Add Sample. So I'm going to scroll down a little bit more. So it's 1. And then I want to 2. Got 6. Just keep clicking up here. We'll get all the way. As you can see, has anybody guessed it right yet? All 12 of them? Not yet. One more guess. Boom. So we're sitting now. We got people, got a few on 4 and 5 and 6, 7, 8. Pretty even distribution, right? We're just doing this. Well, let's go make it even 20 here, so it's easy to add this. Let's say though we wanted to go ahead and take this and get a overall sample size of 100. Okay, so we do 100 shirts. Now it gives us our normal bell curve. As you can see, it's slowly just a nice bell curve right there. It's symmetric. Unimodal as well, because unimodal meaning it has one peak in the actual curve there. So one peak, and that peak looks to be sitting right around 6, which is a 50-50 chance of guessing it right or wrong, right? So majority of the people out of 100 got 6 right and 6 wrong. But how many actually got all 12 right? The highest it goes is 10. So no one in these 100 samples that we did got all 12 right. So if that's the case on a sample, then just off this small sample size, now granted we can make this go even higher, we can knock this up even bigger. Let's put another 100 in there, see what happens. Still plays out. Sorry, I scrolled down a little too far. Still plays out to where out of 200 samples, no one got above 10. So with that, it's highly unlikely that she was just able to possibly guess all 12 correct. So it looks like in the end here, Miss Joy out of the UK has a pretty unique nose. So we'll get into more of this later in lessons, talking about different ways and what all I was talking about as far as unimodal and normal bell-shaped curve and things going on with that. Sounds a little strange right now up front, but we'll get into it and explain it, and you'll get used to hearing it, and you'll be very tired of hearing it by the end of this class. All right, well, glad everybody's here, and see you next time.